All right, in this lesson, we are going to talk about vertical parabolas, and then next time we will talk about horizontal parabolas. And so a lot of this will be familiar from our quadratic unit with a conic spin on it. And so a parabola, the formal definition is the set of all points that are the same distance from a given point in the plane called the focus, and a given line in the plane called the directrix. Okay, and so our focus is this point here, and then our directrix is this line. And so something you want to note about the directrix and the focus is that every point on this parabola is equidistant, and so mainly the vertex. And so this distance is going to be the same as this distance. Okay, and so our equation for the parabola looks similar to vertex form if you're remembering our quadratics unit, where h is the x-coordinate of the vertex and k is the y-coordinate of the vertex. And so whatever is hanging out with y, that's always going to be your y-coordinate, and you take the opposite. And then whatever's hanging out with x, that's going to be your x-coordinate. Again, take the opposite because you're seeing these minus signs. These minus signs mean opposite. Okay, and then the axis of symmetry is always going to be the line that splits your parabola in half. So in this case, it's always going to be x equals, it's a vertical line, and it's going to equal the x-coordinate of your vertex. Okay, so something else that's important about this formula is the a value. And so how you find the a value is the equation a equals 1 over 4p. And p is the signed distance from vertex to focus. Okay, and so your p value will always be from vertex to focus. And it's important because if it's opening up, your p-value is positive. If it's opening down, the p-value would be negative. And a and p will always have the same sign since a equals 1 over 4p. So if p is negative, a is negative. And so if your a value is positive, you'll know you're dealing with a parabola that opens up. If it's negative, it's opening down. And so an easy way to remember that is positive is happy, it's smiling, whereas negative is sad, it's frowning. And so negative, sad parabola. Right, the other thing we're going to be talking about is what is called the focal diameter. And the formula is once you have p, you just take the absolute value of whatever 4 times p is. And so the reason why you want to know that is because the focal diameter is this distance here. And so if you know the focal diameter, you're going to be able to get 2 more points on your parabola. Okay, so let's jump into some examples. And so here we have a graph. We can see that the vertex is at 5, 7. And then we can measure the p-value using the directrix. And so remember the directrix, which is graphed here, is always going to be equidistant from the vertex as the focus. And so that means my focus would be 2 away as well. And so because it's going up 2 to get to the focus, we know the p-value is 2. And so to find the a value, we just do 1 over 4p, which is 1 over 4 times 2, which is 1/8. Okay, and so you can see the p-value in the graph. You don't see p in the equation. You see a in the equation. So p corresponds to graph. A is going to be what you see in the equation. Okay, and so our equation, since my y-coordinate is 7, I'm going to have y minus 7 on the left side equals my a value, which is 1/8, parentheses x minus the x coordinate squared. And so the general form, I'm going to write it here, y minus the y equals a x minus the h squared. And so we just filled in the x coordinate was 5, the y coordinate was 7, and then the a value, which we calculated from p, was 1/8. Okay, next example, they're giving us the equation. And so because there's no parentheses with x, that means your x coordinate is 0. And then here I'm seeing a +4 with y, and so that means my y coordinate is -4. Okay, and so we don't have the p value in the equation, we have the a value. And so here a is -1/6. And so to find the p value, which will help us create the graph, we need to put 1/4p equal to -1/6. So whenever it's negative, just put the negative in the numerator. And so I'm using the formula that a equals 1/4p. And so a equals -1/6 tells me 1/4p equals -1/6. And so from here, you can cross multiply. 4p times -1 would be -4p. And then 1 times 6 would give me 6. And so to solve, we would just divide both sides by -4. And so my p value ends up being -3/2 when we simplify that fraction. And so for the graph, if you want to work with mixed numbers or decimals, that's the same as -1.5. And so let's graph what we have so far. We have the vertex at 0, -4. And then the p value is negative. And so that means I'm going to go down 1 and 1.5 to get to the focus. Okay, and so that's the focus, that's the vertex. Okay, and so my focus is 0 and then -5.5. And then remember the directrix is equidistant. So we're going to go up 1.5 to get to the directrix, which is a line. It's a horizontal line. And so this is y equals, looks like -2.5. That's our directrix. And then our axis of symmetry is always going to go right through the vertex. And so x equals 0 would be our axis of symmetry. Okay, and so the length of the focal diameter is always given by absolute value of 4p. So it'll always be positive. So our p was -1.5. I'm going to use the fraction because that's easier to compute. And so that gives me -12/2, which is -6. Take the absolute value, you get 6. Okay, and so remember, this is the diameter. And so it acts like the diameter of a circle. And so that means the radius on each side would be 3. Just cut that in half. So that means we're going to go 3 units to the right of the focus and 3 units to the left of the focus to get a full focal diameter of 6. So that means I have a point on the parabola here, I have a point on the parabola here, and now we can create our graph. And so your parabola always focuses on the focus. I always say it's hugging the focus and its back is towards the directrix. Okay, and so the domain of this graph is going forever to the left and forever to the right as it's going down. And so the domain of these parabolas are always going to be all real numbers. So negative infinity to positive infinity with parentheses. Infinities always get parentheses. And then my radius, the maximum is at this vertex, which is -4. And then it's going down to negative infinity. And so we're going to say negative infinity to +4. I mean -4. And then the -4 does get a bracket because we do equal that point. So negative infinity, and then we stop right here at -4. All right, my next example, the vertex, I see my x-coordinate would be +4. My y-coordinate would be -6. And then my a value here is -1. That 1 is invisible. And so because a equals -1, that means I know 1/4p equals -1. You don't really need to cross multiply this because we don't have two fractions. Just multiply both sides by the 4p to get it out of the denominator. And so that would give me 1 equals -4p, and then divide by -4. And so p is -1/4. Okay, and so let's go ahead and graph our vertex at 4, -6. And then to get to the focus, because p is -1/4, we're going to go down 1/4, so just barely, -1/4. And to get to the directrix, we're going to go up 1/4. Okay, and so the ordered pair for the focus is going to have an x-coordinate of 4 and then a y-coordinate of -6.25. You can use mixed numbers or improper fractions. So x-coordinate is 4, and then I'm going to use the decimal, -6.25. And then my directrix, if we went up 0.25, this would be -5 3/4. So y equals -5.75. Y equals because it's crossing the y-axis. My axis of symmetry is always going to go right through the vertex. It's the vertical line. So x equals 4. And then now to find the length of the focal diameter, take the absolute value of 4 times p, which is -1/4. That would give us absolute value of -1, which is just 1. Okay, and so that means start at your focus, and because we want a whole length of 1, we're only going to go 1/2 to the right and 1/2 to the left to get our 2 points. And so there's my focal diameter of 1. And then we have the rest of our graph. Notice it's opening down because both p and a were negative. And so domain, once again, all real numbers, negative infinity to positive infinity. And for the range, we are going from negative infinity, stopping at -6. -6 gets a bracket because we have a point there. All right, for the last two, they are giving us information, and then we are writing the equation. And so they're telling us the vertex is -2, 4. And the directrix is y equals 2. So that's going to be the horizontal line crossing at y equals 2. Okay, and so remember, that gives you the p-value. The distance to the vertex is 2, and so that means we can go up 2 more to get to the focus. And so we know that this is going to be a parabola that opens up. They didn't say to graph it, so we'll just sketch it. And so we have our vertex at -2, 4. That's going to give us our h and k. And then we know p is 2. And so to get a, we just do 1 over 4p, which will be 1 over 4 times 2, which is 1/8. Okay, and so that's all we need for our equation. It's y minus the y coordinate equals a x minus the x coordinate squared. And so we'll put in 1/8 for a, h was -2, and k was 4. So our final answer will be y minus 4 equals 1/8, and then x minus -2 would be plus 2 squared. Domain still -infinity to +infinity, but this time because it's opening up, our minimum is the 4, and it's going to +infinity. So 4 with a bracket to +infinity with the parenthesis. Okay, and so if they don't give you a graph, I would do a rough sketch just so you can see what's happening. So here they're giving us the focus and the directrix. The focus is 5, 9, which is in quadrant 1. And so when you make your sketch, you can kind of give you more of quadrant 1. And so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so my focus is here at 5, 9, and my directrix is at y equals 5. Okay, and so remember your vertex is going to be right in the middle at the midpoint. So between 5 and 9 would be a 7. And so that means my vertex is going to be at 5, 7. And I can also tell that this is opening up because it always hugs the focus and then back towards the directrix. And so I can see that my p-value to get from 7 to 9 is 2. And so that means a equals 1 over 4 times p, which is 2, is 1/8. And that's all we need to write our equation. We have y minus the y equals a x minus the x squared. And so be careful and don't use the focus here. We want the vertex. So k is 7, h is 5, and a is 1/8. A lot of people try to use the 5, 9 instead of the 5, 7 for the equation. So my final answer would be y minus 7 equals 1/8 x minus 5 squared. Domain still -infinity to +infinity. And then range, this minimum is 7 at the vertex and going to infinity.